Alright, hey again. I am back with a new video, and this time I am going to be doing something different. I'm not sure how useful or interesting this is going to be, but I'm going to be documenting the build of a tube amplifier from beginning to end, from scratch, starting with nothing more than a schematic. And it's interesting for a couple reasons. Well, for anyone who likes building tube amps and tube equipment, you might find this kind of a unique project, both because of the particular amp that I'm going to be building, and right now you're looking at a schematic of it, probably scratching your head, what the heck is that thing? And also because I set a budget of $200. So I was looking for something to do, and I thought I'd just try a challenge here. A challenge on a couple levels. Now, I've built many amplifiers in the past. Some good ones, some not so good ones. I've screwed some up. Some of them have turned out great. So this time, the goal of this, for me at least, is more of a learning experience, and also just I'm just interested in this circuit for some reason. And this is not a hi-fi amplifier. It's probably pretty lo-fi at that. But it's super simple, and it's interesting for a couple reasons that I'll get into. So my goal here is not really to build, a real super duper hi-fi pride and joy amplifier, but it's just more or less to get this thing to work and to make it the best it can be, given the design limitations. And also, it's been quite some time since I've built an amplifier from scratch, from nothing but a box of parts. This doesn't come in a kit form. There's no printed circuit board, none of that stuff. So I've already started the process of purchasing the parts, and I've gotten most of them from. Oh, and another thing, I want to stay true to form. I want to buy the exact parts that the schematic specifies, and I'll tell you where I got the schematic in a minute, including when they specify paper oil capacitors. I'm going to get those. This old diode right here, this 1N1763, I purchased that new old stock. So for the most part, I want to stick to this schematic and just see what happens, and then if I can get it running, then maybe start tweaking from there. So I've started ordering parts, and I'll show you what I got in a minute. And let me just begin. So the challenge here is just to build it, to get it working and make it the best it can be, just for the fun of it and the learning experience. And I have been doing this for years, but I really haven't documented any of this stuff. But I thought it might be useful or interesting to somebody, maybe, to go ahead and document the progress along the way, from beginning to end, through building, through testing, do some listening samples. Hate to sound negative, but it's probably going to be pretty bad. Just looking at the schematic and knowing what this thing is and what it isn't. So I'm going to start. Let me first tell you where I got this schematic. Came from the ubiquitous and classic RCA receiving tube manual. Anyone that has this manual, and a lot of people have it, it's basically a manual of tube characteristics of almost, well, every tube certainly made in America, but almost every tube ever made, with few exceptions. And in the back of this manual, among many other things that are interesting, They provide a whole series of schematic diagrams for various circuitry, for television circuits, oscilloscopes, voltmeters, preamplifiers, amplifiers. Here's a high fidelity preamp for tape heads, preamp for magnetic phono pickup, 2-channel audio mixer, and so on and so on. Here's one that I built years ago. Not quite the same. I modified it, but so been there, done that. They call this a high fidelity audio amplifier, class AB1. I like class AB1 amplifiers. So this kind of an amp, building this from scratch is really quite an undertaking. A lot of parts, a lot of stuff. But right on the next page, I've always, for years now, I've had this book for, since 1989. Run the numbers. It's January 2014 right now, and I've always seen this circuit back here, and I've always kind of laughed at it. You know, like, what the hell is that? Never really paid any mind to it. They refer to this as a 2-channel stereophonic amplifier, and the purpose of this amplifier was to amplify the input from a crystal or ceramic phonograph pickup, and those are just really cheap phonographs, probably of the kind that would be in the form of like a suitcase that you would carry around, and it was a phonograph with a built-in amp and a built-in speaker or 2 speakers. In this case, it's a stereo amp. Cheap stuff. And so the purpose of the amp, because this was probably for portable equipment, was to keep the weight down, keep the cost down, yet still do the job, and hence the simplicity of the layout here. So this is where I got it, and this is a photocopy of the schematic enlarged. So it is a simple amp, and that's kind of what attracted me to it in the first place. And plus, it has a couple of unique features to it. I say unique, not necessarily in a good way, but so I'm going to start here by just explaining the topology here, and I'm not going to be, in this video, I'm not going to be doing any building yet. I'm going to show you the parts that I have so far, and just basically discuss this. And when I start getting more parts in, then I'm going to start the building process. So first, I'm going to just describe the amplifier, and a couple of interesting things about it, a couple of challenges, and then show you the parts I have and talk about my approach to building it, and then I'll make subsequent videos throughout the process. So let me begin by discussing the topology here, what I find to be interesting just in the sheer simplicity of this thing. Start by, well, you know what? Let me do this. This might be useful to somebody if it's, you already know this, you can skip over it, but okay. Let me readjust the camera. It's on a very shaky tripod here. In general, in amplifier, this is going back to just block diagram theory right here. And power supply. Alright, so what you're looking at right here is overall block diagram of what a power amplifier is. And all of the let me call this control selection. All amplifiers, the components inside of them fall into one of these boxes, basically. And so with any amplifier, you've got your input signal. And typical input signals are going to be from phonographs or CD players or iPods or what have you. Interestingly, a line level signal, the signal that comes out of your typical CD player or DVD, Blu-ray, even line level outputs, not variable outputs like from your iPod or iPad, but just line level, the steady voltage, no volume control, line level like what comes out of the RCA jacks. That is typically 1/3 of a volt that comes out of line level. So, say we have our inputs, and the front end of an amplifier is basically the control and the selection portion. You have your volume knob, your balance control, maybe bass and treble, maybe some filters, and then you have a knob or buttons to select your input source. All fairly simple, straightforward circuitry. Now, the next two stages, the first one is our voltage gain stage, and the last stage is our current gain stage. Now, power is equal to voltage times current. So power in watts is voltage times current. Voltage in volts, current in amperes. So a power amplifier does two things. A power amplifier is not a voltage amplifier alone. It's both a voltage amplifier and a current amplifier. So the first stage of a power amplifier, it takes a small signal and then outputs a much larger voltage. And the final stage of a power amplifier takes that voltage and amplifies the current into a low resistance or impedance load. And in this case, I'm just going to draw a little speaker. That's a horrible speaker. So, because the speaker is a low resistance, it needs a lot of current. This voltage amplifier can provide the voltage, but it couldn't sync or source the current needed by the speaker. And that's what the current amplifier does. This is usually called a driver stage. This is called an output stage. And of course, all amplifiers have a power supply that supplies the necessary voltages to the different stages. And these various stages need different voltages. Now, in this amplifier, there's a single tube per channel. So this one tube has to do all the work. That's one of the interesting features about this amp. Normally with tube amps, let's see if I can go back and... Well, I didn't intend to talk. I don't have a script for this. So I just get to talking and who knows where I go with this. This is that schematic of a high fidelity audio amplifier I showed you earlier. So here's our input right here. Let me zoom in. We have our input, and we go through these various stages right here. These are this is going to be a voltage gain stage, and we're going to have some more voltage gain right here, and then this output stage right here is going to be our current gain stage, effectively. These tubes coupled with the transformer, that whole section, is our current gain stage. So these guys here will amp up the voltage, and these guys here will amplify the current by providing the necessary current to drive the speakers. And then down here is our power supply section. With this simple little amp, there is no discrete stages. And I'm oversimplifying things here. I don't want to get into mathematics or really much more than I've already gotten probably too deep here, but with this simple little amplifier, let me zoom out. Here's our power supply right here. Boy, is that simple. And then a single tube does it all. So we have our inputs, our left and our right channel inputs. Each are fed through. This is a potentiometer, and this is going to control the volume. So we go through a volume control knob, that's right here. And then the next thing we have, the bridging between the left and right channels, is a balance control. So that's our knob that controls left and right balance. Very simple. And then finally the signal makes its way to the one and only vacuum tube. So this tube is going to be responsible for both amplifying the voltage as well as sourcing the current necessary, coupled with the transformer, by the way. So the tube and this transformer act in unity, sort of as one, for lack of a simpler way of stating it. So these guys right here are collectively will amplify the voltage and the current to produce power to the speaker. And it is simple. Now, what to the power supply? This uses a single diode, so this is a half-wave rectified power supply, as opposed to a full-wave rectified power supply. And so now this is interesting right here. You'll notice that there's no input transformer. This is very rare and probably dangerous and probably stupid not to have an input transformer. But it's a power transformer for the power supply. You'll never see this because it's dangerous. That's one of the reasons I'm building it. Back to our high fidelity amp, the power supply is right here. This is the power transformer. This guy's responsible for taking the line voltage from the wall, 117, and isolating it from the rest of the circuit, as well as stepping up and stepping down voltages necessary for the various stages. There is none here. Nada. This 117 volts right here, this is the line voltage from the wall. Plugs directly into the wall. And then, now I'm going to tell you, I'm going to be plugging it into an isolation transformer for purposes of building it and testing it. Not a good idea to have that circuitry exposed without plugging it into an isolation transformer, which is just a transformer that you plug into the wall and it outputs the same line voltage as the wall, but it is a transformer, so it provides isolation and it provides some safety features by disconnecting the voltages from earth ground. I won't get into that. Anyway, so line voltage from the wall passes through a single diode half-wave rectifier. It goes through a filter. These capacitors store energy, but they're also a filter to get rid of the noise or the ripple. And then they feed the voltages necessary for the tubes. These guys here are the heaters for the tubes, the filaments. They correspond to this little guy right here. Vacuum tubes, you see the nice orange glow, sometimes blue. Those are the heaters, or the filaments inside the tube that heats up the cathode in order to boil off the electrons so that they're attracted to the plate. This particular tube, this 60FX5, and this is another reason I wanted to build it. It's a very old tube, goes way back, and this tube was designed for this purpose, for amplifiers and other applications that could be run directly off of line voltage 120 volts. Their plate voltages, characteristics, period, are designed for line voltages without being stepped up or stepped down. So, hence the heaters of the 60FX5 each require 60 volts. So you can see that the two heaters are put in series, 60, 60, 120. Interestingly, most vacuum tubes When you look at the first number of a tube, like 12AX7 or 60FX5, that first number usually designates the filament voltage. So 12AX7 will be 12 volts. There are tubes that begin with 6 volts, and so on. So the 60FX5 requires 60 volts on the filaments. The two are put in series, so 60, 60, 120, boom. No separate transformer needed for that. Most tube amplifiers, as part of one of the power transformer taps, is the tap for the voltage for the filament. So this is going to be interesting. Now, I was going to get into the load lines. I'm not going to do that, but I've been toying around trying to reverse engineer this thing. I've got the data sheet for the tube, and I was just trying to kind of reverse engineer it to figure out what voltages I'm going to be expecting on the plate and where the quiescent point is, and I think I know where it is. I'm not going to get into this right here. This is too detailed, and quite frankly, I don't like running numbers anymore. I like tinkering, building, repairing, and so forth. But I always like to start with, because this schematic doesn't give me voltages to expect, I like to, and that's always handy when they do, then I always like to reverse engineer a little bit so I can at least get in the ballpark so I know that nothing crazy is going on when I finally build it. Okay, so that's enough of that. I'm going to be building this from start to finish. Let me just hit pause here and then briefly discuss some of the interesting things I'm going to have to do to build this with a $200 budget. Okay, got the camera off the tripod now. Anyway, this is my box here. Whenever I start a new project, and I haven't had a project in a while, but I usually start collecting parts and putting them in a box like this. This is a box that light bulbs came out of from Home Depot. So, all these parts down here, and they provide a nice parts list at the bottom here. I have already ordered from various sources, from Parts Express, from mostly from eBay, because I had needed some new old stock stuff, and Amazon. And the most expensive parts were the transformers. Output transformers are always the most expensive. And I had to buy, I found these are 3K transformers. The primary is 3K. And I got 3K transformers that have taps on the secondary for 2 ohms, 4 ohms, 8 ohms, and 16 ohms. That's nice. However, for those who know something, and this is something I don't know because I've never done this before, I couldn't find a transformer within my budget for a single-ended output, this is a single-ended output. So I bought the transformer that has a center tap for push-pull amplifiers, but each side is 3K. And something tells me that these transformers are designed differently as far as the core, and now without getting into detail, I don't know how well this is going to work in a single-ended mode. Basically, I'm just going to use one tap, one side of the primary for each side right here. So one transformer for the left channel I'm going to use, between the brown and the red, and same for the other transformer. Not this, I have 2 transformers. Get the other one out. And just ignore this other side right here. And I hope that works the same as buying a single-ended transformer. I don't know, I've never done it before. I'm going to find out. But these transformers were the most expensive part. They were $60 for 2 of them. So that ate up a good chunk of my $200 budget. And believe me, that's cheap for output transformers. The rest of my budget is, all the caps and the resistors and the potentiometers and such. So I've gotten some of the capacitors in that we need. These are great. These are neat. These are paper and oil capacitors. You don't see these around much anymore. They are Russian. New old stock. And there's some caps. And I've got some resistors in. These are good quality. Power resistors, and got some metal films. Metal film. So I've got that so far, and got some terminals, some input guys. RCA. That's pretty much what I have right now. I'm still waiting on a host of other parts. So when I got done adding up the cost of all the parts, I didn't really have a budget for an enclosure or a chassis. And so I'm going to do something that people are going to laugh at, but I'm going to use a cigar box. And I've done it before. One of the things I've done is when I'm prototyping and building an amp, I use a cigar box because they are just the right size for an amplifier chassis. And they're easy to drill into and mount things to and that sort of thing. But ultimately, if one's going to be using an amp, you really want a metal chassis that's earth grounded. And if this amp amounts to anything, I might do that. Maybe not. So the cigar boxes were cheap, and got 2 of them for $10. They're the right size. So it's going to look funny. Anyway, so yeah, this is my my workshop. I've got Heathkit Harmonic Distortion Analyzer. I like this thing. This basically works identically to the Hewlett-Packard, the old Hewlett-Packard distortion analyzers. Everything's the same. Got an oscilloscope with a spectrum analyzer, fast Fourier. It's a digital storage scope. Got an old, and I like this actually better, but an old analog scope. That's my Heathkit tube tester. Audio signal oscillator, low distortion. That's my function generator, digital voltmeter, dummy loads. This guy here is this silly looking thing right here is my capacitor discharger. Clip this onto ground, and inside this probe right here, that's a nail at the end of it, but wrapped up in there and soldered up is a 470 ohm power resistor, and various parts, and my mini Variac. I have an isolation transformer. I don't know where it is. Heat shrink gun and solder, and I don't really have anything of super high quality, nothing elite. Soldering iron. I don't have any elite. I don't like elite stuff. I don't like I'm better than you equipment. I like making do with old, cheaper stuff. I get more satisfaction out of building something good with with inexpensive and cheap and used equipment than I do with I'm better than you gear. No thanks. This is my Fisher 500B. These speakers here are some Fostex guys that I built, and this is what I use for testing, listening test on the bench. Back of the Fostex, and you know, other things here and there. So this is where I do my work. This is the parts department over here. It's all my vacuum tube reference manuals. I have more upstairs, and I've got a library of textbooks from my college days. But I don't enjoy crunching numbers anymore. I used to design these things from scratch, and I got kind of sucked the life out of the hobby, so I don't do that. I like going with schematics, reverse engineering them, then building them, then modifying them, and improving them. It's kind of what I like doing. That's what I'm going to be doing here. So thanks for watching. I'm going to be posting more videos. Probably my next video is as soon as I get the first thing that's got to be done is when I get the cigar boxes. I need to mount the transformers and get the tube sockets mounted and get all the big stuff mounted and then start building. And the first thing I want to build is the power supply. Power supply first, and then test it and see what kind of voltages we're getting out of the power supply under various loads, and make sure everything works. Oh, and I am making one modification, even though I said I would keep this. They've got a switch right here. I'm moving that switch back up to over here. Because this is going to be the ground side of the amplifier, and I want to switch the hot side, and also the fuse, of course, would always go on the hot side, so that if the fuse blows, then you're touching the ground side. Now, I'm not sure how much relevant that's going to be in an amp that's not going to be earth. Actually, if you plug it into the wall, it will be earth grounded. So, yeah, I'm moving the switch up here so that when the switch is off, nothing is hot here, and also if the fuse blows, nothing is hot. So everything will be grounded. So if you plug this in directly into the wall, this will be earth grounded. But if you use an isolation transformer, then it's quite irrelevant. Okay, thanks for watching. I am finished here, and I don't think I have anything else to say. So good night, and hopefully you find this interesting. And if you do, then I'm going to be documenting this from beginning to end. And regardless of what happens, if I can't get this thing to work, I'll show you. Or if it turns out to be, horrible, I'll give you a listening test of a horrible amplifier. But I want to do my best, and I like challenges, and I don't think there's ever been a time I couldn't get something working. So hopefully this one doesn't get the best of me. Cheers.